Let's go to LeetCode 502 IPO. And you say that LeetCode is going to start the IPO, and it gives us an initial capital, which is W. That means if the current if we can only take those kind of projects which have capital smaller or equal to this W, right? And in a once, for example, this kind of profits and the capital, those kind of have a same length that represent the project. Once we select a project, the profit will add to our W. And we can invest some more. If we have more W, right, we are going to invest, we are able to invest more projects. And you say that we can, at most, invest K projects. It asks us, so what's a maximum profit? Not the max final maximum W we have, right? Capital, that is actually final W. So what we do is that we select those kind of projects which has capitals smaller than current W, right? And the things that for every project which is we are able to do, right? We are going to pick this kind of project which has the most profit. So what we're thinking about that is that we need to have a data structure which put those kind of project which has capital smaller equal to W, but we are able to get the profit with a max profit more efficient. So what we think about is that we may use a priority queue, right? And there is a condition that is K. We can select only K project, right? So that means that we need to iterate at least K, right? So for every the things that we have these limitations. And for every project, what we do is that we select those kind of project every K, right? We at least iterate K times. We select those one which we are able to invest, select those with the most profit. So once this project poured out from our priority queue, right, max heap, will not reuse it anymore, right? So we use a pour method. And once we pour it, we add our profit to a W. And keeping looping this, right, until we have the K project finished, or we have the priority queue being empty, right? Which one reach first? For the priority queue empty, that means our current capital is not great enough to invest any projects. So let's write a code for this, right? So we know the profit and capital they should have the same length. That means we have n projects. And so we need to compose a project array. Int n2, right? While we do is for int I equal to 0, I smaller than n, I plus plus. We're going to have a project I 0 equals first one we can have capital, right? Capital I, and then we can have profits. And we know we need to have a priority queue, right? So we are going to have priority queue. The priority queue should be sorted by its profit, because for every doable project, we need to get the most profit one. Next queue equals new priority queue. So we pass into array, right? So should be integer compare the profit is one, right? A that means that we need also need to sort those kind of projects by its capital, right? So that we don't need to every time we just need to when there is new W, right? So that means that if we invest an project, we add profit to our W, right? So that means this kind of W is keeping increasing. If in this case, what we do is that we don't need to empty our priority queue anymore. That means for later, if we have a new capital, it should always be greater. That means we are able to handle more projects. So if we sort this project by its capital, right? So we can keep those who already be able to handle project in the priority queue and add a new to it, right? Of course, there may have some project being selected and being popped out, but since the project which is being kept in the priority queue should all be able to handled by our current W, right? So in this case, we should sort our project by its capitals. And let's have an int result equal to 0, index equals to 0, right? So for int, we can only investigate k, right? K objects. So what we do is that while this kind of index is smaller than n, and W is greater or equal to project index 0, right? In this case, we'll put all of the projects we are able to invest to priority queue, right? So max queue, we should offer all of those projects index, and we have index increase, right? So that since that we are say if this kind of max heap is not empty, then we are have our result should we don't need this result variable, right? Actually, we just add it to W. So we have W plus equal to max heap, but we use the pool, right? Pool. And pool, the first one is profit. And else, if it's empty, that means we are not our current W is not great enough to invest any projects. Then return W, or we can use a break, right? And in the end, we return W. So if there are n project here, this is n log n sorting, right? And the worst case is that this n project, they are all put in the priority queue. That is also an n log n, right? But actually, k should be smaller equal to the actually the worst case is we put an n project in the priority queue, right? But since that we may not need to put all of them, so it's possible k log n. But since that the worst case is still n, n log n in the priority queue. The space is linear, right? So that is n o n, right? Let's write a Python code as well, right? So Python code, we know the Python has those kind of list zip function, right? Equals list zip capital and profits, and we are going to have project sort, right? The reason we want to sort is that we make sure that capital is smaller or equal to W. So we have n max heap and index equals length profits, and the max heap should be this one, right? For in range, okay, what we do is that while this kind of index is smaller than n, and the project index 0 is smaller equal than to W, right? In this case, we are able to use heap push max heap. We'll use negative project index 1. So we sort this one by profits in a priority queue, right? And we should have index plus equal to 1. And we'll say if max heap is not empty, right? Then we're going to have W should plus equal to we put the negative values to it, right? Max heap pop, max heap, and else we should break. And in the end, we just return W.